Okay, we've got everything we need installed, so let's go ahead and run it. Now, with MRJob, there's a couple of ways you can actually run your MapReduce script. One is locally, and this doesn't actually use Hadoop at all. So you can just use the MRJob framework to sort of simulate MapReduce. And this is useful for just testing things out on your own desktop. So instead of actually developing on your Hadoop cluster and using Nano, you can actually develop on your desktop using a nice text editor or whatever development environment you're used to, Anaconda or Canopy or something like that. And to do that, you would just type in Python from the command line, and then the script file name, and then the input file, and that's it. And that will just run it locally. Now, obviously, if you're running just on your own PC, you don't want to be running with an entire data set if it's a massive data set. So often it's useful to create a subset of your data just for testing and development purposes, and refine that on your desktop before SCPing that up to the cluster to actually run on the real data. Now, when you're ready to actually run it on Hadoop, you can use a syntax like this. Again, Python, script name, and then we're going to do -r Hadoop, and that just tells the MRJob framework that I'm actually going to run this on Hadoop, a Hadoop cluster for real, and it's going to actually use a resource manager and a Hadoop application manager and actually distribute that job if it makes sense to do so, right? And we also have the final parameter of the input data again, and this could be either a local file that will get copied to HDFS for you automatically, or more often you will actually have an HDFS ://URL that specifies a path to existing data on your HDFS system. If we're talking about big data, you're probably not going to have it sitting on your hard drive and copying it up, right? So that's most likely going to be an HDFS URL there. This thing in the middle, this --hadoop-streaming.jar, kind of a quirk of Hortonworks and MRJob. MRJob doesn't really know where to find the jar file for Hadoop streaming on the Hadoop sandbox, so we have to manually tell it where it is. Now, on other platforms like Amazon's EC2 or Elastic MapReduce service, you wouldn't need that. It knows how to find it automatically. But for the Hadoop sandbox, we do need to specify exactly where Hadoop streaming lives as a parameter. So that's what the --hadoop-streaming-jar parameter is saying, which will be user HTTP current Hadoop MapReduce client Hadoop streaming.jar. Okay, so let's go do it. So before we kick this off, let's remind ourselves what this script is actually doing again. So let's type in nano ratingsbreakdown.py one more time to take another look at it in the nano editor. So again, we're importing MRJob and MRStep from the MRJob package. We're defining a class named ratingsbreakdown that inherits the capabilities of MRJob. It contains a single step that has a mapper function called mapperGetRatings and a reducer function called reducerCountRatings. The mapper getRatings function just takes in each line, splits it up by a tab character, and extracts the rating and the number 1 as its key value pair. So for the mapper, we're extracting rating 1 key value pairs. Then our reducer function takes in each individual unique rating, 1 through 5, and a list of all the 1 values associated with each rating. And then it yields the key, which is the rating, 1 through 5, and the sum of all those 1s, which is going to end up being the count of each rating type. And finally, this little bit of boilerplate down here tells it to actually kick this off and run it if we're running it from a command line prompt. So let's hit Control X to get out of this and actually run it. So first we'll run it locally, like we talked about. And to do that, we can just type in Python and then the name of the script, ratingsbreakdown.py, followed by the input file, which is u.data. And again, we're running locally, and that was pretty quick because, 100,000 ratings isn't that much for a computer these days. And there's your results. So you can see there were 6,000 some odd 1-star ratings and 21,000 some odd 5-star ratings. And the most popular rating type is actually a rating of 4 at 34,000 ratings. So you can see people are pretty judicious about what they give 1 star to, but they're relatively generous with 4 and 5 stars. So interesting distribution of ratings there. Okay, so now let's actually run this using Hadoop. So before we might have been developing on our desktop or something and we were happy with the progress, and now we want to run it for real using the actual Hadoop cluster. So to do that, we can type in Python and the name of the script, which is ratingsbreakdown.py. -r Hadoop tells MRJob that we actually want to use Hadoop to run it this time, using the Hadoop installation on the client node that we have that we're running from. And again, we need to tell it exactly where the Hadoop streaming jar is. This is just the bit of code that integrates MapReduce with Python, or anything really. instead of using Java. And we need to give the path for that /user /HDP/current /Hadoop -MapReduce -client /Hadoop -streaming.jar. Let me double check that. And you double check that too. Make sure you didn't get any typos in there, because it won't work if you mess up even one character. I think that looks right. And finally, the input data file. Now I'm just going to be using the u.data file that's in my home directory here, so I can just type in u.data. But in the real world, again, you're probably dealing with larger data files that don't exist just on your client node here. And in that case, you would type in something like hdfs : and then the path to your data file on your HDFS file system. But in this case, we have it just sitting here, and we're going to let MRJob copy that to HDFS for us. So let's go ahead and kick that off and see what happens. Okay, so far so good. You can see it's copying that file to HDFS like I talked about, so that all of the different tasks running on the different nodes have access to u.data, and it can access different pieces of that while it's mapping it in parallel. Now, since it's actually a very small job, it's not really going to distribute it, and especially since we actually only have one virtual machine here, so this is what's called a Uber job that's actually running everything on one instance. But it's small enough data that we can pull it off. So we're running the first step, which is mapping everything and starting to reduce it. Shouldn't take too long. All right, we got a bunch of output statistics there, and we got the final output coming back. And there you have the results, same as last time. So hey, it worked, but this time we actually used Hadoop for it. And again, we have, the most popular rating type is 4, and the least popular is 1 star. So out of all the different star ratings available, 1, 2, 3, 4, or 5 star, these are the counts in the data set of how they were distributed. And we actually used Hadoop and MapReduce and Hadoop streaming and Python and the MRJob package to do all that. Congratulations, actually running all this stuff for real. It's a little bit of an accomplishment. You should be proud. You can actually say that you can actually run Hadoop code and actually look at it. But hey, that's not enough. I want you to actually write your own MapReduce code as well. So if you're familiar with coding at all, I'm going to challenge you in our next lecture to actually expand on this and do something even more interesting. So we'll do that next.